And I'm going to give you an overview of hydrogen and fuel cells and what we're doing in the market today, all the activity with hydrogen. Basically, what we're doing in a fuel cell is instead of burning hydrogen, we're reacting it at a low temperature. Same end effect, but without the externalities. This is an electric bus, but you take out most of the batteries and you put in a fuel cell and fuel storage. We've got over 1,300 buses on the road now, powered by Ballard, and lots of miles and kilometers behind us. Buses with demonstrated over 30,000 hours of fuel cell stack life. And not just ours, some of the older buses that AC Transit has been running have gotten over 30,000 hours as well. It really shows that the technology is capable of lifetimes that are enjoyed by present combustion engines. And when you compare hydrogen to gasoline, you see some real advantages. Not only is hydrogen non-toxic, but it also is very buoyant and very diffuse. When it gets out, it can be contained in how it's released, as shown in the study done by Ford, comparing two cars that are intentionally given a fuel leak and an ignition source. The gasoline you see pooling on the floor, creating vapors, engulfing the vehicle in flames, whereas the hydrogen can be contained to a single release point and safely evacuated. Comparing it to gasoline and diesel, there's so many personal safety advantages, particularly regarding toxicity and ingestion. One thing that you should bear in mind that critics of hydrogen say is that most hydrogen is produced from natural gas and fossil sources. That's true, but most of it is not used for transportation. Only a very small amount is used for transportation. More than that is made by zero emission hydrogen. Most of it's used for refining. So
Linde is a global industrial gas company. We've been supplying hydrogen for well over 75, 80 years globally. One of the key factors is it's important to be able to condition your hydrogen. And we do that in a number of different ways. And one of the most prominent way is with liquid hydrogen. We actually take a hydrogen molecule and we cool it down to a very low temperature, about 20 degrees Kelvin, and we liquefy that product so that we can transport it. Now, the benefit of that is that we can transport a higher supply of hydrogen molecules, typically about 10 times versus conventional gas hydrogen trailers, and we can use it at very efficiently at fueling locations for especially for the mobility market. President Biden has recently passed the Inflation Reduction Act, and that is going to be another funding source that helps reduce the cost of hydrogen and infrastructure that's being deployed across the United States. So the combination of the infrastructure bill and the Inflation Reduction Act, which is commonly referred to as a production tax credit, are two ways that are really going to help meet the goals that the DOE has set out in terms of the $2 per kilogram. We have the first commuter rail operating on hydrogen in northern Germany. We're heavily involved in the OEMs as far as trucking is concerned. Also getting involved in marine activities and rail. So all those markets are opening up in terms of the use of hydrogen.
Good morning, everyone. My name is Matt Grigori. I'm a technology development manager with SoCalGas's Research Development and Demonstration Team, or RD&D. Our mission is to build the cleanest, safest, and most innovative energy company in America. And we've committed to achieving net zero greenhouse gas emissions in our operations and delivery of energy by 2045. That's our Aspire 2045. We recently proposed to develop what would be the nation's largest green hydrogen energy infrastructure system to deliver clean, reliable energy to the LA region. The RD&D program funds researchers to develop new technologies that we think will benefit our customers and all Californians through energy savings, reduced environmental impacts, and improved safety and energy reliability. Our program is divided into 5 research programs that span the entire energy delivery value chain. About the Clean Transportation RD&D program. This program focuses on minimizing the environmental impacts related to the transportation sector, particularly through the integration of hydrogen and renewable natural gas. We recently announced that we're working with Ford Motor Company on a demonstration project to reduce commercial fleet emissions by developing an F550 Super Duty hydrogen fuel cell electric truck. The study provided a high-level assessment of the components required to convert Ontario International Airport into a hydrogen ecosystem to support a zero-emission regional and short-range aviation and transportation. Preliminary results suggested that converting just 3 types of ground service equipment, these are the vehicles that run around on the tarmac servicing the aircraft, so just converting 3 types of ground service equipment to zero emissions would reduce CO2 emissions by 52% and NOx emissions by 89%.
Hi, good morning. My name is Roland Cordero. I'm the Director of Maintenance and Vehicle Technology at Foothill Transit. And this morning, I'll just share our journey to zero emissions early this year. Our zero emissions program began in 2010 with 3 short-range en-route charge Proterra 35-foot buses. We added more buses in 2014, 16, 17, and 18. And our latest addition were 2 double-deck battery electric buses manufactured by Alexander Dennis. In 2017, we received our first fleet of Proterra extended range buses, which supposedly had a nominal range of 251 miles on a single charge. Our actual findings operating the buses in actual service showed only an average of about 150 miles, 159 miles. In order to operate these buses on line 280, which we had planned to electrify, we needed a way to extend their range. In 2018, we hired Burns & McDonnell to prepare a study for a plan to transition to 100% battery electric bus by 2030. The report was issued in 2019 and indicated that it will cost Foothill Transit about $120 million to transition to 100% battery electric fleet. The battery electric buses are a 1.5 to 1 replacement and requires us to increase our fleet size to operate our current service. The cost to build fueling infrastructure for over 100 buses costs about $6.6 million. And scaling the fleet size will only require minimal cost by adding another hydrogen tank. The fueling process takes about 10 minutes to fill each bus versus hours to charge an electric bus. California offers several incentive programs to assist in lowering the operating and capital costs of both battery electric bus and hydrogen bus. Low carbon fuel standards, or LCFS, allows agencies to earn credits from operating zero emissions fleet. Other programs include the HVIP hybrid and zero emissions truck and bus voucher incentive project. There's also a VW mitigation, which offers up to about $400,000 for fuel cell electric bus purchase. In order for us to move forward with our hydrogen fuel cell program, we had several procurements that was required. We had to issue the following procurements to move forward. We purchased our fuel cell buses through the California State Zero Emissions Vehicle Program. We issued procurement for the design, build, and installation of fuel cell fueling stations. In order for us to move forward with maintaining and repairing our fuel cell buses in our maintenance building, we're required to install hydrogen detection systems and upgrade the ventilation. We also entered into a contract for the operations and maintenance of fuel cell station and provision of liquid hydrogen.